So dear students, after completing the first topic of paper number 12, namely electronic communication, that is fundamentals of the communication system, that is by studying the fundamental concepts which are needed to proceed for the next topics of the electronic communication. Today we are going to start with second topic, namely known as modulation and demodulation. When we have studied the first topic, in the general block diagram of electronic communication system, we represented the two blocks. One is a transmitter and second one is receiver. While describing these two blocks, I told you that modulation is the process that is used in transmitter. Without modulation, no signal is transmitted to cover a large distance. And demodulation is a process that is used in the receiver. Hence, these two aspects becomes very essential to understand the further concepts of the electronic communication. And that is the reason why the topic modulation and demodulation is introduced in the syllabus. Students, we are going to start with modulation and demodulation in details. We are going to study the topic of demodulation and modulation with this particular lecture plan. First, we are going to study the definition of modulation as well as demodulation. Then we are going to study the need and importance of modulation. We are going to study types of modulation. We are going to study details of amplitude modulation, then power in amplitude modulation, concept of DSB, SSB and VSB, that is concept of double sideband, single sideband and vestigial sideband. Then we are going to study another type of modulation, that is frequency modulation. After that, we are going to study the details regarding the digital modulation. Then we are going to cover the process of demodulation, where we are going to study two demodulating circuitry. One is for analog modulation, namely envelope detector, and other is for digital modulation, known as a ratio detector. After that, we are going to study the multiplexing techniques used in electronic communication, especially TDM, that is a time division multiplexing, and FDM, to be referred as the frequency division multiplexing. To proceed further, we will introduce the definition of modulation. Friends, modulation is the process by means upon which some of the parameter of high frequency carrier wave is varied in accordance with that of the parameter of signal to be transmitted or signal to be modulated. This definition includes two kind of signals combined together so as to develop third type of the signal at the output. One is the signal to be transmitted or signal to be modulated. This means that the information, the source, the expressions, the views, the opinions, analog signal, maybe digital signal, maybe any code, all these are to be the signals transmitted or signal to be modulated. When these signals are to be transmitted, one of the parameter of this particular signal to be transmitted, according to this variation of the parameter of the signal to be transmitted, the high frequency carrier wave parameter is going to be changed. In short, we can say the signal to be transmitted is superimposed on the carrier wave, and the resulting signal we can call it as it is the modulated wave. Thus we can say modulated wave contains the transmitted signal to be transmitted superimposed on high frequency carrier wave, and then that modulated signal travels either through the channel, through the cable, through the wire, or is being fed to the transmitting antenna. Then transmitting antenna converts this modulated radio frequency signal into electromagnetic radiation. It travels through the space, going to be act as a channel and reaches to the receiver. Students, I think the definition of modulation is clear to you. Once again I will repeat, modulation is the process by means upon which some parameter of high frequency signal known as the carrier wave is varied in accordance with the parameter of the signal to be transmitted. Then to proceed further, why modulation is needed and what is the importance of modulation in the communication? Need and importance of modulation in the process of communication. What happens if the signal is not modulated? So that makes you understand the meaning of need of modulation. That is going to represent the importance of modulation. Just to understand that, we can say that whatever the signals which are required to be modulated, all those signals are in the form of frequency spectra. As in the first topic, even though it is not part of a syllabus, we have discussed it, the frequency spectrum. That includes the range of frequency which is being used for the serving the different purpose in the communication. So all those signals are existing in the form of a frequency spectrum. And this frequency spectrum can't transmit directly in the atmosphere to cover a long distance. So that's why we can say the signals are generally in the form of a frequency spectra. Hence, the direct transmission in the atmosphere, it is not possible. Therefore, the frequency spectra of the signal are needed to be modulated. So this clearly gives why modulation is necessary. As being the frequency spectrum, transmission of the frequency spectrum directly it is not possible in the atmosphere. Hence, it is necessary to be modulated. Means the parameter of that particular signal to be transmitted is to be changed in accordance with that of some of the parameter of the high frequency carrier wave. Apart from this, after being modulation, signal can be radiated easily by designing suitable amplifiers and antenna at this frequency. This means that designing of amplifiers and antennas becomes easy if the signal is modulated. Second one is bandwidth can be adjusted smaller or larger than the original signal so as to improve the signal to noise ratio. Means because of modulation mainly only you can adjust the required bandwidth, maybe increase or maybe decrease than that of the original signal so as to improve the signal to noise ratio. Friends, in previous topic we have introduced the signal to noise ratio. Signal to noise ratio decides the quality of signal transmission, and that's why it should be improved by using the modulation technique. If the signal to noise ratio is more, noise is less and signal is more, and we are interested to transmit more signal and less noise so that a fruitful communication it is possible. Third one is it allows shifting of signal frequency to pre-assigned band. Because of modulation only you can shift the signal in a required assigned frequency band. And last one, which you already studied in the last topic itself, because of modulation only height of antenna, transmitting antenna and receiving antennas are going to be reduced. Friends, previously we were looking height of antenna in the every building, on the every top of the building will be more. Nowadays, as the development that took place in the electronic communication system, antennas with that particular height we are not observing for the receiving purpose. And the reason behind that is the techniques, improved techniques which are used in the electronic communication. So all these factors makes us to understood the need of modulation and also the importance of modulation in the electronic communication system. Student, we will proceed further just to understand the types of modulation. Friends, different types of modulation techniques are used in the transmitter. Depends upon type of the signal to be transmitted, type of the frequency to be transmitted, type of the carrier frequency being used. There will be different types of modulations. Modulations are classified according to type of signal to be transmitted into two types. One is analog modulation and second one is a digital modulation. In analog modulation, signal to be transmitted is in the analog form, whereas in the digital modulation, signal to be transmitted is in the digital form. The analog modulation is further classified into the different types. One is amplitude modulation, second one is angle modulation, next one is frequency modulation, and next one is phase modulation. So all these are the types of analog modulation. Out of these types of analog modulation, we are going to study two types of modulations. One is amplitude modulations and second one is the frequency modulation. Second type of the modulation is digital modulation. That includes pulse amplitude modulation, abbreviated as PAM. Pulse duration modulation, abbreviated as PDM. Pulse position modulation can be abbreviated as PPM. Pulse code modulation, which can be abbreviated as a PCM. Amplitude shift keying can be represented as ASK. Frequency shift keying, which can be abbreviated as FSK. And phase shift keying, which can be abbreviated as the PSK. So all these are to be referred as the types of digital modulation. All these digital modulations are studied conceptually up to some extent in this particular topic. Friends, today we stop here only. The rest of the aspects, that is details regarding the first type of modulation known as amplitude modulation, we are going to start in the next period.